Welcome back, everyone. My name is Corey, and this is the series where we are creating a custom programming language using C++, Flex, Bison, Google Test, ICU comes along later. And yeah, just whatever. We're writing it in a console window that is Vim and everything from scratch, 100% live coding. A lot of this as I've said before in other videos, I have written a complete programming language twice in preparation to record this video series, but I'm doing things completely different in some places, and yeah, the only references I'm using are my own notes of, like, in my help documents of where the settings are. For example, like in Flex and Bison, when you set an option, I've got now in the document, in the comments, I have links. All right. Oh, and Doxygen. Yeah, we're using Doxygen to generate our documentation automatically. And I'm doing it all right here in front of you. Our goal for today is we want to add comparison operators. And what are those comparison operators? Those are less than or equal to, greater than or equal to, strictly equal to, and not equal. And so there's 6 of them. And we're going to see if we can get it all done in this one episode. I know how I'm doing most of it. I don't know how I'm doing all of it. So we're just going to jump in and see how it goes, see how quickly we can get all this done. As usual, we're starting off, well, I'll show you. We're starting off right here. Episode 20 was the very last commit, and there is nothing. If I say get status, there's nothing up my sleeves, right? We're starting from where we left off. And let's see, one of the things I want to do is we're reusing the AST node binary class that we created, was it 2 episodes ago? I don't remember. Recently. And so let's just go into that. This is going to be the source and the no, I want to do the include first. No, I always get them wrong. AST node binary and the source for AST node binary. And the goal is we don't, do I want to say it that way? I'm sorry. Now I'm arguing with myself. I'm going to go ahead and open some files that I know we're going to need. We're going to need the include for the garbage collected class that we've written and the source for garbage collected. I know that we'll need those. And then we're also going to open the source for the AST node, not cast, AST node. No, I'm wrong. Computed expression. Computed expression. And the include for computed expression. Oh, wait, I did those backwards. See, I always get them backwards. I want to do the include first. Include for computed expression, and then the source for computed expression. And we'll need more files than this. I can go ahead and open the include for computed expression. Let's do the integer first. Source for computed expression integer. My caps lock key keeps getting in my way. And then the include for computed expression float. The source for computed expression float. And we know that we're going to need Flex and Bison. Oh boy, that's a lot of files, but okay. Again, there's, we can look at a buffer list. There we are. There's 12 files there for us to look at. This is great because we don't have to start with the make file. Every other time we've had to start editing the make file first, and not this time. Okay, so where do we start off? The AST node binary. The reason we need this is because our less than, equal to, greater than, or equal to are all yeah, actually right here, this is the easiest way to say it, are all binary operations. And so in this case, this is going to be so we'll say less than to no 2, 3, 4, 5, 6. Okay. Less than that's or equal, but greater than equal, and then we will have equal and not equal. And now start lining up some stuff. And let's change this. So modulo is correct. Less than, that's going to be there. Less than or equal to, there we go. Greater than or equal to, strictly equal, and not equal. Now, by the way, I'm going to stop here and just remind you that if you're making your own language, you can make these whatever you want. If you don't like the double equal and you want it to be a single equal and do something different for assignment, that's up to you, right? What is it? What is that language? It was my first language, actually. Pascal used a colon equal for assignment. That's fine. You can do that. And not equal, I think it's SQL that uses that symbol. So you can do whatever you want. I'm going to do this because why not? It's what I'm used to seeing. Okay, and so those are the binary operations, and we don't need to add anything else to this. Let's go to just the next buffer. How about that? AST node binary, and we need to add some text, so it's less than or equal. This is more human facing, so it'll be, I want it to look nicer. Greater than or equal, and then we'll say strictly equal, and this will be not equal. And maybe I shouldn't say strictly equal, because some people mean that there's no type conversion, that it's exactly. In fact, I'm going to change that. I'm going to remove strictly equal just so that it's not a point of confusion with anyone. And so now these are our descriptions that matches up with it. And if you've been watching this for any length of time, you know that I say things in the exact same order sometimes, like add, subtract, multiply, divide, modulo. I do the same thing with my comparisons. It helps me make sure that I maintain an order. And now we've got these. what am I doing? I'm going to do this because 2, 3, 4, 5, 6. That should be all of them. And now we're going to put the exact same thing here. So it is case less than, than equal, greater than, greater than equal, equal, and not equal. All right. And now opcodes. Oh, we didn't open our opcode file, so we'll have to add that. Do we want to just say this less than? Yeah, no, my caps lock is on. There we go. Less than equal. Greater than. Greater than equal. So couldn't we just call that GTE? Yeah, in fact we may. LT, LTE. And I have another reason for something I'm planning in the future that this will be better, I think. GTE, and we'll say EQ and NEQ. There we go. Less than or equal to, greater than equal to, equal, and not equal. So, yeah, we need to add these opcodes. So let's on the right hand side, I'm going to go ahead and get it started doing its compilation. It's not going to like this because the opcodes aren't defined yet, but who cares? Test watch. There we go. Yep. And now we're going to edit the source. Not source. I always do that. Include opcode. And now, where do I want to put these? I think I like putting them before the casts. So it's going to be LT and I'll say pop RHS, pop LHS, push LHS something R. RHS. And why am I doing that? Because I'm about to copy this in 2, 3, 4, 5, 6. Okay, now we'll put the less than back in. LTE, GT, GTE, EQ, NEQ, and now just put the correct symbol. Less than or equal to, greater than or equal to, strictly, well, equal to, whatever, and then not equal to. So that has all of our opcodes in place. And we haven't done anything about how to execute those opcodes yet. If we write anything with those opcodes, it's going to fail. But that's all right. Well, in fact, I'm going to go ahead and write a test. And we'll just do this at the bottom. And all I want to do is 2 is less than 3. And it should be true. That's what we're hoping for. And I'm going to compile this, and it's not going to be. That, oh, I've already used this expression, not, this is comparison. And actually, this is probably just going to be less than. All right. And it's saying, yeah, it's true, and or it's not matching up. That's fine. We have a failing test. Okay, let's get back on track. Where were we? So we added the AST node binary. That is, we added our types to that. And in both of those, now garbage collected. I said I know we're going to need to do that, and we're going to come back to that. We'll come back to garbage collected. Computed expression. Let's go there. And so this is buffer 5, and what we've got to do is we need to have two think so not, and these are your type conversions, so I'm going to put it right here. And what are we looking for, Corey? Okay, well, what we're looking for is, first of all, instead of Boolean, we're going to have less than. Okay, and this one is going to be equal. And between those two, we can get all of the other 6. Why? Because if something is greater than, then that means it's not less than and it's not equal. If something is less than or equal to, that means it is less than or it is equal to. If something is greater than or equal to, then that means it's not less than. So by only requiring our types to write those 2 tests, less than or equal, we can cover our bases. And so our help file, our help thing is going to, let's say, compute the, I know I could just say less than, but it's, less, yeah. Comparison. All right, and this is going to be compute the that's an equality test. And what do we need? We need this value here. And yank that, go back down to our less than, and also our equal. And what else? We need the parameter. The garbage collected value to compare against, and I'm going to do that there. There we go. And now it's going to complain because these don't exist. Well, it might. We haven't tried to reference it, so it might not care. But that's all right. So, which one are we on? 5. So we need to go to 6. Yeah, undefined reference. That's fine. Is equal. Did I put that after not? I think so. And we had this as less than and equal. And we need to pass in, nope, this maybe unused. Oh, nope, it goes down the less than. Get it in the right spot, Corey. And the equal, same thing. And now let's just correct our, don't know how to, and I'm just gonna compare these values because that's what it is. It's a comparison. I think that'll work, and that should fix the compilation problem. And at this time, it's compiling, it's running, but we haven't. Right now, Flex doesn't know how to recognize less than or equal to or greater than equal or not equal. Doesn't know how to do any of those yet, and that's okay. We haven't told the rest of our programming language doesn't know how to. So let's do that now. Let's go to Flex. Which one is that? Flex is number 11. Whoops. And we're going to go down to, on these special operators, I'm going to double check my notes on if they need, to be escaped. I don't remember. And it's not something worth messing around on. You just look it up. The equal doesn't, but the less than and greater than do. Okay. So, where do I want to put them? Closing, that's the not. Let's start here. And 2, 3, 4, 5, 6. Okay, just getting it all on screen here. Going back up, and I'm going to say less than or equal to, greater than or equal to, and now I don't need that for the double equal, and do I need it for the does not equal? No, I don't. So does not equal. And now we haven't created these things in Bison yet, but we're going to say, how about just less than, caps lock again, there we go, less than EQAL, greater than greater than equal and not equal. Note qual. All right, now it's going to complain because it doesn't know what any of those are. So we've got to go to Bison. If this was 11, Bison should be 12. It is indeed. And now we're going to have to declare all of our tokens. Percent token something something 2, 3, 4, 5, 6. And it's going to be less than equal greater than equal and I just realized something I want to change. But that's okay. Not equal. I'm going to call this equal compare as opposed to equal assign. And it's going to complain about that, but I don't care. Buffer 11, go back. We're going to call, instead of equal, this is going to be, why did I undo that? Equal compare. C-O-M-P, compare. Go back to 12. And now let's write the helpful user-friendly thing. So less than or equal to, greater than or equal to, double equal, and not equal, or no note qual. Equal, oh, compare, C-O-M-P. I did that in the other one. Just want to make sure that we are yep. All right. So now I need to refresh my memory. In the binary, I'm coming back to number 12, but in the, there we go. Less than equal, greater than equal, equal, not equal. That's fine. Why? Oh, we need our precedents. Where should these go? Do I have this handy? The answer is no, I do not. I'm looking up just C++ operator precedence. There we go. And again, we have to make sure we're doing it the same order as them. And we see down here on the, there we go. On right, we're looking for plus, minus, and multiplication, division. And there it is, plus, minus, multiplication, division. And so the checks are relational. Okay, relational, then equality. So it is going to be, from our perspective, the relational above plus and minus. Yes, and those are, as you can see over here, it tells, come on, give me the, there we go. All of these are left to right. See, some are right to left. We've got those. And yeah, we'll add pre-increment, post-increment, stuff like that. There we go. But anyway, yeah, left to right and comparison first. So This is going to be equal and not equal, followed by less than or equal to, greater than, and greater than or equal to. There we go. And now go down and let's get these expressions. So I'm just going to steal that one. Okay. 1, 2, 3, 4, 5, 6. So less than or equal to, greater than or equal to, double equal, and not equal. And now the names are less than, equal, greater than, equal, and of course, last but not least, not equal. And save that, move this out of the way. Should give us, our test should give us errors now. It's not. it's gone into an infinite loop. There we go. Why? Probably because, like I said, I'm missing something somewhere in terms of my dependencies, and so it didn't rebuild something that it needed to rebuild. And I just had to figure it out sometime. At least that's my theory. We'll see if it happens again. Oh no, it's... it's not happy. All right, I'm going to press forward with the assumption, the faith that this is going to work itself out. So what do I need to do? I need to say, so I've done the binary stuff. I haven't done garbage collected yet, but I'm going to need to in just a moment. My computed expression, I did that, but I haven't added it to integer or float. I've done the scanner, parser, the opcode, and I've added at least one test. So we're down to needing to get the integer, the float, and then, well, let's just do the garbage collected. And then we'll tell the program, because that's not in this list, but the program how to compute it. All right, so garbage collected. Well, no, I'd rather do the program first. So that doesn't exist yet, so it's going to be our source program, the dump. We've got to do 6 of these. Two, 3, 4, 5, 6, and this is going to be LT. LT, LTE, LTE, GT, GTE, EQ. Oh, wait. No. This should have been GT, GT, GTE, GTE. So you can't just let your brain go on autopilot. EQ, EQ, and NEQ. NEQ. So that should allow us to dump them. And now I don't want to have to retype all of these, so I'm going to yank 29 lines and now edit the include for not include source. See, I keep getting it wrong. Program execute. We're going to put it right before the casts. All right, and we need to do a stack check of 2. So I'm going to you know what? D2. Because the modulo, almost everything is right in that, with the exception of the sign. And I can go back and fix that. Not the sign, the operation that we're doing. 4, 5, 6. And I know it's probably faster to go up, but again, I like staying in the same order. That way I know what I'm doing. So that's less than or equal to, greater than or equal to. Now we've got our equal and not equal to. Okay, now these are garbage collected values, so I have to add to the garbage collected now. How do you handle these 6 things? Okay, so let's go to garbage collected, and that is 3 and 4. Perform a something. All right. 2, 3, 4, 5, 6. And this is going to be a less than. You know, I'm just going to greater than, so I don't have to move greater than or equal to. Wait, less than, that should have been less than or equal to. Less than or equal to. This should be greater than. This should be greater than or equal to. This should be a double equal, and then the last one should be not equal to. And now the names, less than or equal to, greater than or equal to, double equal, and not equal. And now it's going to complain that I haven't created, oh, it's not compiling at the moment because we put a stop to that for the moment. Okay, and now some of you may know about the spaceship operator. And I'm just going to stop here for a moment. I wanted to use the spaceship operator. I thought, oh, this is going to make my job so much easier. The problem with the spaceship operator is, at least according to my understanding, that it must return not a garbage collected value. And that's what we need it to return. But one of the ordering types, strong ordering or stuff like that. And yeah, that's not what we need. So, all right. Let's steal the... Where's the modulo? Why is it down there? Okay, we're going to... put these in the same order as everything else, but I'm going to steal the modulo, put it here, and now... The inside of all these are going to be different, okay? I'm just going to tell you that starting off. So I think this is going to be less than, and we will go from there. So for 2, 3, 4, 5, 6. All right, we know that this is going to be the less than or equal to, greater than or equal to, double equal, and not equal. Okay, now I'm going to, for this, it's easy, equal. Sorry, my brain stopped for a moment. Equal there. Equal, but I can put a not in front of it because we've already written the not. That's good. So for the less than, so greater than or equal to is not less than. So the only problem is the less than or equal to and the greater than. So the problem is we don't have an or, and we don't have an and for our garbage collected. Do we need to write that as well? Maybe. No, I think we can get by without it. The problem is, so I'm just going to mark this as a to-do just for the moment so I can find it. And then the, which one did I say? The greater than? Yeah. And that's just so, like I said, I can find it in a moment. And we're going to come back to this. Actually, our computed expressions. Let's look at the computed expression really quickly. So we're in for computed expression is buffer 5. We've got this thing of is equal, where we can give it true. Let's do that. So this one is going to be less than is that's a garbage collected, so we need to do is, did I have an underscore? Let's just is underscore equal. Why did I do that? Who let me do that? I'm using camel case everywhere else. Okay, it's going to be a refactor in the future. For right now, yeah. For right now, okay. Is equal, and that'll give us a bool. And this is, sorry, my do I want to do it this way? Okay, I'm going to back up. What's the problem? What am I going up against? What if result less than gave us an error? We should return that error. So if type ID of result is equal to type ID computed expression error, if that's the case, I just want to return result. Yeah. Okay. Now, the OR can be short-circuited. An equality check, well, it may return an error. So, I'm going to call this result 1. Result 1. Result 1. Result 2 is going to be equal. See, we're going so fast, and then all of a sudden it's the little wrinkles here and there. Anyway, result 2 is that, but we're going to say there we go. You know what? Forget that. I'm going to say if this does not equal computed expression Boolean. Yeah. Then return it. Should I do that? No, I'm not. Sorry, I'm arguing with myself. Result 1, that's going to be a garbage collected value, is equal with true, return result 1. Otherwise, result 2, that means it was false, so we need to check the equality, and now we should just be able to return result 2. So, if result 1 gave us an error, that gets passed back, because that's what we want. We want errors to propagate up. If it's equal to 2, then that's fine. We just stop and pass it up. Otherwise, we say, okay, well, is it equal? And then whatever that is, we return result 2. Yeah. And now we're going to do that. Put it there. That should work. See, all of these could be condensed. And I might do that. I'll think about it. But let's fix the operator greater than. One thing at a time. So in this case, operator greater than is where it's... Wait, less than or equal to, that's fine. And greater than is not less than or equal to, right? So, oops, return Can I use it in this way? In the same way that I could say this is yeah, I can say that. And I can say star this is double equal to the right hand side. Just use my overloaded operators. They should be fine. Probably be inlined. And I think the last thing I want... Do I want to... No, I'm not going to change these yet. I will at least for these. I will say... return. There. Two more. Return. Return. I'll fix the others later if this has not broken. How about that? It may still give me a loop, but we'll see. Oh, computer expression error is not declared. Well, how dare it? It's not like I left something out. Okay, yay! It's not an endless loop. It just says doesn't know how to compare these values. Good. Where do they get compared? That would be the integer and the float. So, which one? Computed expression integer or 7 and 8? Let's write those. B7, negative not, and now I'm going to steal the modulo. And instead of modulo, it's going to be less than. And the other one is going to be equal. Less than and equal. Okay, now it's going to complain that those don't exist, but that's all right. We're about to create them. Where's the modulo? There we go. Yank 11 and negative not, and we'll put it right there. This should be less than, right? Okay, that's fine. Yank 11. There, it's going to be in there twice. One for less than, once for equal. All right, and now, if it's an integer, oh, I should have copied a different one. Let's go to add. Move back down to less than and equal. Okay, great. For less than, if the right-hand side is an integer, convert it to right-hand side integer so I can get its value, and I am testing for less than. That's fine. If it's a float, I should be able to just test for less than. Do I have to do it? Don't know how to compare these values. If it's a float and this is equal, to compare, and what is it not? Yeah, it doesn't like the narrowing, which is good. Oh wait, it's on a different one. Oh, okay. Yeah. What am I returning for each of these? This is a Boolean. 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 Will it do the comparison all right, or do I have to specifically typecast those? So far it's working. Let's look at the test, which is 14. Evidently it's not. Oh, buffer 14. If I make this a 2.1, will it read it as, well, it should be false. Wait. 2 is less than 2.1. Yeah. You're right. I really need to test it with something else then. No, I think we're okay. So B9 is this is our, well, B7. Let's just less than and equal to B9, not, there we go. Now we have our less than or equal to here, B10. I'm going to grab the add. How many lines do I need to yank? There we go. Yank 14. Put it up here after the not twice. Less than. And this is going to be Boolean. Less than Boolean. Don't know how to compare. Might as well go down and don't know how to compare. Go back up here. This one is equal. And we're returning Boolean. This is also a Boolean. And I mean, everything should compile just fine. Now we just need to write tests. So, where were the tests? 14. So I know 3, 4. Five. Okay. So, well, let's go from here. I'm going to say 2 is less than 2 should be false. 2 is less than 1 should be false. 2 is less than 3 should be true. Now, in case you're wondering what I'm doing, my thought is I want to do above, equal to, and below. Just to make sure it's correct. And now I want to do the same thing but with a float on the right-hand side. A float on the right-hand side. And then a float on the left-hand side, and then a float on both sides. Okay. And that should check everything, and then we'll do one more for testing something that shouldn't work. Okay. 2 is less than, so it should be 3, 2, 1, 3 dot, 2 dot, 1 dot, now 2 dot, okay. And all those should, just save it. Oh yeah, I can't call them all P1, can I? Nope. That's okay. 2, 3, 4, 5, 6, 7, 8. Nope. Undo that. 8, 9, 0. Whoops, that should be an insert. 11, 12, 13, 14. And now change all of these. That's a P1, 2, 3, 4. Anybody knows a faster way? Let me know. All right, and 2 of these should still fail. No. Oh. Because true. True. You know what? And false. That should also fail. All right. Now let's see things fail, please. Good. Okay. Don't know how to compare these values. That's what I wanted to see. Okay, so 13 should be before I go any further, this should take us down to just 2 failing. That is correct. And now everything is passing. Okay. That was for that was for less than. How are we doing time-wise? I probably don't want to know. 112. Can this be knocked out in 10 minutes? Getting tests for 5 new ones? Probably not, but you know what? With that attitude, who's going to get anything done? Okay, so let's do this. We got... I just need to see how far down. 32. 1, 2, 3, 4, 5, 6. Less than or equal to. Now, for all of these, I want to... for 2... I don't know how to... colon, so it's 291, comma, and I think 32 lines later is going to be 322, substitute less than for less than or equal to. Okay. And now that means I'm going to... That's going to become true. So it should be true, true, false, true, true, false, true, true, false, true, true. Wait, Going too fast. True, true, false, false. Okay, I think that's right. Now, just for the moment, this should be greater than. I'm not going to do these yet. Greater than, equal. I'll do them one at a time. This should be equal, and the last one should be not equal. Not equal. Okay, but if everything passes, okay, so it didn't on 295. Two is less than or equal to, so that's not, and that means it's on P5. So it's not getting the equality. Okay, that's why we do this. I thought that I had all my bases covered, and y'all probably saw the difference, but oh well. Let's. I'm going to go ahead and change all of these. Yeah. This is 324 to 356. Why not? What am I changing? My less than. This needs to become a greater than. Okay. This one is 357 to 389. I'm going to change the less thans to be a greater than or equal to. Okay. For my equal, I've just got two more, and then I have to make all the trues and falses. For this is 390 down to 422, and we're going to change the less thans to be a double equal. Okay, and then the last one is 423. If somebody knew how to do these with relative numbers, that would be a handy thing to know. I just don't know it off the top of my head either. To 455, and I'm going to change the less thans to be not equal. By the way, the Boolean should know how to do the not equals. This should be a true. And I was about to write it, and I was like, no, it's just going to further complicate things. So I did, okay, so I did less than or equals. We know we've got problems there. Greater than. 2 is greater than 3. That should be, false. 2 is greater than 2 is false. 2 is greater than 1 is true. So this is true. So it's false, false, true. False, false, true. False, false, true. False, false, true. And those all should be right. Okay. Now, 2 is greater than or equal to 3. That's false, true, true. false, true, true. I'll just do it. False. Oops. True. True. False. True. True. False. True. True. Okay. And that should be correct. Now for equality. It should be false, true, false, false, true, false, false, true, false, false, true, false. And now, 2 is equal to true should be an error, but false is equal to true should be false. Now the not equal. Last one. True, false, true. True, false, true. True, false, true. And true, false, true. And then we already got the last. Okay. Now, it's not going to like some things. That's all right. Now we're having to debug. Let's just start with the first one, 295. Or you know what? Let's start the last one. Why not? That way it's always at the bottom. 15. Yeah, I didn't write one for equality for computer expression Boolean. So we can do that by editing the include for computed expression Boolean and adding guess I don't have one here that I can copy. An equal, but it needs to pass in a const garbage collected ampersand. What do I call it? RHS? I think so. And now I need to edit the the source computed expression Boolean, and just write it from scratch. Computed. There we go. Computed expression Boolean. There we go. Under equal, and we're going to pass in a const garbage collected ampersand RHS. This should be const, and we're going to say if the type ID of RHS is equal to the type ID of computed expression Boolean. Then what does this look like? Auto RHS con is equal to, is that how I normally do it? This is I don't care that it's broken at the moment. 18, and I'm going to compare this against computed expression integer 7. That is not the right one. 8. Yeah. Static cast with an ampersand. Okay, fine. Auto ampersand. That's what, okay. Right hand side conversion is equal to static cast as a computed expression Boolean ampersand, and what is it? Star RHS. That way we can get to its value, and computed expression Boolean, and we're going to pass it in this arrow val is equal to RHS dot val. Else I know it's not ready, but that's what I wanted. B18. Don't know how to compare these values. Oh, cost. Const, and it's probably going to say, yeah, what? Oh, RHS conv. Okay, now P14. Go back to the test. Where is the test? The test document is number 14. And it doesn't... Oh, yes. Okay, so this is something I was thinking about. An error, it should pass through, but then we're passing it through a not. And... so the not should pass the error through if it is an error, right? Yes, it should. So this is going to be a not a source. Yes, it is source. Computed expression. basically, here's the problem. Include computed expression. And I've got all of these things that if I try to add something to add, subtract, multiply, divide, modulo, negative, not, less than, equal, integer, any of these, whatchamacallit, the error should pass it through. Yeah, that's what it should be doing. So, what's the fastest way to do this? We need our computed expression error. See, we don't have we've got an is equal, and now we need, let's compare this to V7. So for example, all of these. Add, subtract, multiply, divide, modulo, negative, not. All of these should just, if it's an error and it's trying to perform an operation on an error, the error should just return itself back because we want to preserve the error. So, add, subtract, multiply, divide, modulo, negative, not. Less than, equal, integer, float, boolean. Yeah. That's going to say it's missing some stuff. That's fine. We're about to edit the source for computed expression error. Oh boy. Garbage collected. Computed expression error. Some dunder. And it's probably going to be taking a const, maybe unused, const garbage collected ampersand RHS, and it's const, yeah, and it's going to be return this. It's going to return itself. How many of these do we need? B19. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 of them. Okay. So yank 3, and that means I need 11 times P. There we go. And we're just going to say add, subtract. I know some of these will have to remove that garbage collected, but we'll get inside. Multiply, divide. There we go. Modulo. Oh, what are they now? Negative, not, less than, equal. Okay. Negative, not, less than, equal integer float Boolean. And now it's going to complain negative does not have anything. Not does not have anything. And it's probably no, I can't just return star this. Why? Because I'm a computed expression and not a... So the question is, can I create... Yeah, this should be fine. Collected make error, and I'm going to give it this message. That's the first thing I know. I just want to make sure that that one compiles. This is probably the only one that I MSG. Wait, computed expression error. Oh, it's error. And now the question is that a pointer or a... Now it's probably... So it's for line 30, but we got past 26. Okay, fine. Is there another one? Yeah. Almost done. See, we haven't even solved the problem yet. I know, we're getting there. All right. No declaration matches the integer const. So oh, yeah, you don't pass anything to that. That's why. So that's simple enough. All we need to do is same way for the float. Making progress. Okay, now we can go back to our test, which is, was it 14? Okay. And the last one is 354. So false is greater than true. Okay. it's evaluating it as true, and it should be an error. So why? Because the way we implemented greater than. So what we did is okay. Let's go back to the garbage collected.cpp. Buffer 4. Wow, we've got 20 buffers open. We're down to buffer 4. And so for these, we said so let's look at what happens when we say greater than. It says we'll compare the less than or equal to. What's the less than or equal to for two booleans? It says, is it less than? That should be an error. Then it says, well, is it an error? If it is, return result 1, which is the error. So it should have been an error, and then take the not. But what is the not? It's calling not. Shouldn't that return? Again, someone's probably seeing the problem here. And this has gone on longer than I wanted. I wanted to have all this done in an hour. Didn't happen. Okay. However, I'm expecting that there's a few other issues. So I'm going to double check my... well, there must be, because we've got other failures. And what are they in? They're in less than equal and greater than. Not greater than equal. Why? Because greater than equal just uses the less than test, and the less than is correct. However, less than equal uses the equality as well. And greater than uses less than or equal to. So we've got a bug somewhere in this one. It must be. So let's look at it. First of all, we're using less than. We know that that works. Or at least all of our tests for it work. And now we're saying, well, if the type of it that's why I call y'all my rubber ducks. Call y'all, who is this? Who's watching? Whoever is watching, right? Rubber duck debugging is the idea of taking a rubber duck and putting it on top of your monitor and talking to it, explaining your problems to it. Well, I have no idea if anyone's listening right now. There's just a camera on top of my monitor. Yeah. And it was in talking through each line, I just realized, yeah, I had a does not equal. And it should have been no. If it is an error, then just return the error. And now, look. All tests are passing. Yay! Oh boy, this was a big one. But look at this. In an hour and a half, we got 6 new operators added. We added some robustness to the error info. And let's look at the overall changes. So, get status. Big. Okay. Get diff. We've got our bison stuff. That's fine. We've got our flex parts. So the computed expression, we added our less than and our equal tests. And less than equal, the computed expression float, computed expression integer. Okay. This is in garbage collected. We had to add all of our tests for that so that we could, again, the only reason for doing this was so that we could just use the, I hate the word syntactic sugar, but it really is. It's just adding, making it very nice to work with the class, making it very intuitive so that we could use it with the, how you saw it there, just with the less than and nots and all that other stuff. I'll point it out in a moment. Okay, so we have our friendly printout. We've got, let's see, computed expression, that's fine. Our errors, all of our error handling, our float, that's all right. Our execution stuff, our tests. There's a lot of code in this. And by the way, one of the things that kills my comment to code ratio are my tests, right? Because I don't write a lot of comments in them because usually they're pretty self-evident what it's testing. But what I was referring to just a moment ago about having the nicety of, dare I say, the syntactic sugar is okay. I didn't see it. It's in here somewhere. Oh, yeah. These right here. To be able to write this. To say, just do the less than or equal to tests and then take the not of it. But it's because I already wrote how they should behave. There's a not somewhere in here, right? I really hope so. Oh, yeah, we'd already written the not. So, yeah. I looked at it all. It all looks good. Let's do this. Let's do git commit. What is our message? Add all comparison operators. Less than, equal, greater than, equal, double equal, and whoops, and not equal. Dash AM. 627 lines written in this time. No wonder. Actually, yes, I'm feeling a burn here, so I should probably either change my posture or something. There was a lot. Okay. Let's do our docs. Oh, wait. The last thing I want to do, always, 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 before I give up on the committing is make clean, make test, make sure it compiles from scratch. And in the meantime, we'll do our rm-rf docs and then make docs-pdf. There we go. We still pass all of our tests, so that's good. We've got our... do I still have this open? No, that's the operator precedence stuff. Oh, yeah. There we go. We can refresh it. And what did we add? Let's look at our... Oh, we didn't add any classes. But if we look in AST node binary, And somewhere, these operations, we've got all of these operations now. Okay, if we looked at opcodes, we would find those new opcodes. Yeah. That's good. No, I didn't mean to do get diff, get status. And it should just be, that's fine. Get add docs. Make sure it was all, yep. And what episode number are we on? I never remember. Oh yeah, episode 21. Hey. That's great. Episode 21. And with that in mind, get push origin master. Let's take just a moment. Get tag. This is episode 021 with a message of the same. (021) and it is live. All right. Well, again, thank you. I know it's a lot of typing, and that's kind of the point. It's I don't like some of these channels that it's like they don't show you the stuff. They fly through it. It's hard to understand it. And maybe even I'm moving fast for you. You're probably saying, no, Corey, I watched this on double speed because you're so slow. And then I fast forward through it. Maybe. I don't know. But this is the speed that my brain works. And for writing code, I'm enjoying this. I'm hoping that you are too. What are we going to be looking at next? There's something I want to look at with the error messages. I think I want to change the way it passes back for the compile errors, because I want to start writing some tests for compile errors as well. But now that we have our comparison operators, I want to maybe we should do the logical and logical or. The problem is in order to do that, we have to write jump instructions. Yeah, we do. We have to write jump instructions in our code. And that's because of something called short circuit evaluation for or statements and for and statements. So yeah, we're going to have to that, and we need we need a null. What do I mean by null? We need a null type, a null object, a computed expression of type null. So we might be adding that as well. But again, just overall, this is making good progress. Once again, hey, hope you have a great day, and I'll see you next time. Bye.